The cytoskeleton. Cytoskeleton is a network of protein filament extending throughout the cytoplasm of all eukaryotic cell is just extending throughout the cytoplasm and all eukaryotic cell, and it is a network of protein filament that's called cytoskeleton. Rule. What is the rule of cytoplasm? Structural framework. Cell shape. Rule of cytoplasm. Structural framework. Cell shape. Cell movement. General organization of cytoplasm. General organization of cytoplasm. Number 4. Cell division, where mitotic cell division is involved. Track for the transport of materials. Cytoskeleton used the track for transport of materials. And the last one, long neuronal axons. Long neuronal axons, cell surface projection. There are three types of cytosolic fiber. Three types cytosolic fiber. Number one, actin filament. Number two, intermediate filament. Number three, microtubules. Actin filament, intermediate filament, microtubules. Actin filament that provide actin filament provide what? That provide mechanical strength and resistance to shear stress. Number two, microtubules determine what, where, how. Is determine the position of membrane. Mainly is determine the position of membrane enclosed organelle. The membrane enclosed organelle, which is the membrane enclosed organelle, that position by microtubules and direct intercellular transport. In the intercellular transport, microtubules can direct the intercellular transport system. Actin filament. Actin filament determine what? Actin filament determine the shape of cell surface. The shape of cell surface and necessary for whole cell locomotion. When the cell need to locomotion, actin filament is involved. So here the three types of filament: intermediate filament, microtubules, and actin filaments. Intermediate filament provide mechanical strength. Microtubule determine membrane and closed organelle. The determine key what is the membrane and closed organelle positions and direct cellular intercellular transport. And number three, actin filament determine the shape of cell surface, the shape of cell surface, and whole cell locomotion. Intermediate filament. Now, here I want to know about intermediate filament. What is intermediate filament? How it made? Interfilament made up smaller subunit that themselves elongated and fibrous. Actin filament and microtubules made of subunit. It's also made of subunit, mainly subunit joined to another subunit and make a elongated and fibrous thing. So intermediate filament, actin filament, and microtubules, all of three of them made up of a smaller subunit. And intermediate actin filament and microtubules of subunit are compact, that are in compact. Here, actin filament. What is the actin filament of subunit? The actin filament subunit is globular actin. Microtubule subunit is tubular subunit. Actin filament subunit is globular subunit, and microtubules of subunit is tubular subunit. So globular actin subunit for actin filament, tubular subunit for microtubules. All three types of skeletal filament form as helical assembles of subunit. These three types of cytoskeleton filament forms as helical assembles of subunit. Three types of skeletal polymer. They are also polymer, and their interaction they held, and those monomer are also made to polymer, and these polymer are held together by weak non-covalent interaction. Three types of cytoskeletal polymer held together weak non-covalent interaction, which means their assembly and disassembly occur rapidly because of what? Because of weak non-covalent interaction. Without covalent bond being formed, without, because here not it is not a covalent bond. Because of it is not a covalent bond, it's being formed or broken. And here non-covalent interaction and weak non-covalent interaction for held together the polymer. Protofilament. Protofilament is what? What is the protofilament? It is a long linear string subunit. Protofilaments are long linear string of subunit joined end to end that associate with one another, join end to end that associate one another laterally, just laterally. Those kind of long linear subunit join end to end, just end to end, join just end to end, and associate. Those are associated with one another laterally. Typically, protofilament, typically protofilaments twist around each one another in a helical lattice. In a helical lattice. The first thing, the protofilament subunit is long linear string subunit. And second thing, they join end to end and associate one another laterally. Associate one another laterally. And protofilament twist one another. Two protofilament twist one another in helical lattice filament and a dynamic structure. There's a dynamic structure. The initial process of nucleus assembly. Initial process of nucleus assembly is called filament nucleation. If we need to filament perfectly, if the filament need to grow perfectly, first thing is need to happen the nucleation. And the nucleus process is initial process. Initially should be do a nucleation for filament growing. So then when the polymerization is initiated, the polymerization is initiated in a test tube containing a solution. So how can we make the mainly what we need, the filament? So the filament made in a test tube. The polymerization is initiated in a test tube containing a solution of pure individual subunit of pure individual subunit by raising then temperature rising the salt concentration. There is an initial lag phase. The first phase is initial lag phase. There during which no filament observed, just nucleus. Just nuclei are assembled slowly. Nuclei are assembled slowly in the initial lag phase. Rapid filament elongation during subunit add quickly. Secondly, rapid filament is elongation. Rapid filament is elongation during subunits add quickly onto end of the nucleated filaments. Onto ends of the nucleated filaments. Rapid filament is rapid filament elongation is happen when the subunit add quickly and where the subunit add end of the nucleated filament and those subunit add quickly and this thing is called rapid filament elongation. Steady state. Steady state. The rate which steady state is what? Which is the rate of addition. Steady state is which the rate of addition of new subunit to one filament end. Subunit is at end of the filament and is exactly balance the rate of subunit and then what happened also dissociation is happen Dissociation is happen then, and from the end also, and something like addition, rate of addition and rate of dissociation is balanced, and it is called steady state. Some kind of state where rate, where addition is occur and also dissociation can occur, and the rate of addition and rate of dissociation is balanced by when the rate of addition is continuous and then exit, which is balanced by the rate of subunit, which is dissociation from the end, and that is called steady state. The concentration of free subunit, when the free subunit is left and those free subunit of concentration in solution at the point is called critical concentration. There are the new term in this topic, critical concentration. When critical concentration is formed, critical concentration is called some free subunit left in solution, and those have concentration. So concentration of free subunit left in solution at this point is called critical concentration. The value of critical concentration have value, and which is equal to the rate of constant or subunit is lost by the rate of concentration is equal to what? It is equal the rate of constant for subunit is loss. We know we know subunit is loss and subunit is added. So which we know that some kind of subunit is loss and some subunit is addition. So rate of constant subunit is constantly loss and subunit is constantly addition. The rate of constant for loss subunit divided by the rate of constant subunit addition equal to critical concentration. When the rate of constant subunit is divided by the rate of constant subunit addition, the measurement is equal to critical concentration. Here the figure, firstly nucleation lag phase, secondly elongation phase, thirdly steady state phase. Here the actin subunit and nucleation occur, then oligomer growing actin filament, then actin filament with subunit coming off and coming on. Microtubules are formed. Microtubules formed. Now, here the description about microtubules. Microtubules also formed. Microtubules from protein filament. It is all formed by protein filament. Protein subunit from protein subunit of tubulin. So microtubules and tubulin. Subunit of tubulins. Tubulin subunit itself heterodimer formed. Tubulin subunit itself a heterodimer formed from two closely related globular proteins is called alpha tubulin and beta tubulin. Alpha tubulin and beta tubulin. Those are globular protein. Alpha tubulin and beta tubulin are globular protein. And tubulin is subunit. Tubulin subunit itself heterodimer because of alpha tubulin and beta tubulin, those are tightly bound by non-covalent bond. Those are tightly bound by non-covalent bond. A microtubule is a stiff and hollow cylindrical structure. Microtubule structure is a stiff, hollow, and cylindrical structure built from 13 parallel protofilament. Microtubules built from 13 parallel protofilament composed of alternating alpha tubulin, also a beta tubulin molecule. Composed to firstly alpha tubulin and beta tubulin tightly bound and from tubulin, and this tubulin subunit is added to grow a protofilament, and 13 parallel protofilament build a microtubule, and when it is look like hollow cylindrical structure, stiff and hollow cylindrical structure.